Alrighties everyone, welcome to your pre-lesson video today on congruent triangles. So let's get started. Alright, so what are congruent figures? So remember, in your previous 2 weeks we have talked about like what congruent means, which means literally identical, exactly the same, right? So now with congruent figures, right, the corresponding angles of congruent figures are going to be congruent, they're going to be identical. Same thing with their sides. So their corresponding sides of congruent figures are going to be congruent. So let's look at this example that we have here. Right, so we have triangle RST and we have triangle XYZ. So see how it's actually rotated, right? So they don't have to be in the same orientation. They just need to have the same angle and the same sides for them to be congruent. So let's look at the corresponding angles, right? So we look at this example, and there it's all labeled for us already, right? So angle R is congruent with angle Z. Angle S is congruent with angle Y. Angle T is congruent with angle X, right? Now, because these are all congruent, which we know that the two triangles are going to be congruent, right? If we weren't told that the triangles were congruent. Now, the other way to check also is to check the sides. So if we look here, line RS is going to be congruent with line ZY, right? And remember, in Introduction to Geometry, when we were talking about notations, the order that we state these statements are really important because we know R matches Z. That's why we say line RS and line ZY and not line YZ, right? So line RS is congruent to line ZY. Line ST is congruent with line YX, and line RT is congruent with line ZX. From all this, we know that the two triangles are congruent, all right? And so we'll play around with this during your deep dive lesson as we see how the questions are presented, all right? Now, another important thing to know is how do we prove triangles are congruent? All right, so this doesn't necessarily come out per se in the ACT and SAT math, but it is very, 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 very handy to know how to prove that it's congruent. All right, so with triangles, there are 5 ways, which is SSS, SAS, AASA, AAS, and HL. And we're going to see what all these stands for. So SSS stands for, as you can see, side, side, side. And what this states is that if all 3 sides of one triangle are equivalent to the corresponding 3 sides of the second triangle, then the two triangles are said to be congruent by SSS rule. So if we look, AB is congruent to PQ, all right? BC is congruent to QR, and AC is congruent to PR because all 3 sides are has like a corresponding congruent side to the other triangle. That's why we know that triangle ABC is congruent to triangle PQR. All right, and that's SSS. Now, SAS is side, angle, side, and this states that that if any 2 sides and the angle included in between the sides of one triangle are equivalent to the corresponding 2 sides and the angle between the sides of the second triangle, then the 2 triangles are said to be congruent by SAS rule. So let's look. We know that AB is congruent to PQ. We know that AC is congruent to PR. And we know that angle A is congruent to angle P, based on the SAS rule, right? Because you can see side, angle, side, side, angle, side, and they have corresponding congruent sides. We know that angle ABC is congruent to angle PQR, and that's SAS. All right? Now, for the other way we can prove a triangle is congruent is by ASA, which is angle, side, angle, which states that if any 2 angles and the side included between the angles of one triangle are equivalent to the corresponding 2 angles and side included between the angles of the second triangle, then the 2 triangles are said to be congruent by ASA rule. So let's look. Angle B is congruent to angle Q. Angle C is congruent to angle R. And line BC is congruent to line QR because of ASA rule, right? Because they all have corresponding angles and sides. We know that angle ABC is congruent to angle PQR. All right. Now the other one that we have is AAS, which is angle, angle, side. And now how does this differ with angle, side, angle? Let's take a look. All right, so AAS is when two angles and a non-included side, which means that it doesn't have to be in the middle. So as you can see, this side here is not in the middle of the two angles that we're given, right? So AAS, AAS. Anyways, so when two angles and a non-included side of a triangle are equal to the corresponding angles and sides of the other triangle, then the triangles are said to be congruent by AAS, right? So again, we know that angle B is congruent to angle E, angle C is congruent to angle F, and AC is congruent to DF, right? So there's a little bit more of proving how AAS works. So by angle sum property of triangle, which remember is angle 1 plus angle 2 plus angle 3 will equal 180 degrees, right? So in this case, angle A plus angle B plus angle C would equal 180 degrees, and angle D plus angle E plus angle F would equal 180 degrees. Because of how similar they are, right, we can tell that angle A plus angle B plus angle C would equal to angle D plus angle E plus angle F. And then from here, because of remember our transitive property, there we go. Angle A plus angle E plus angle F would equal to angle D plus angle E plus angle F, which means that angle A and angle D are equal to each other. Therefore, because of angle, angle, side, right, we know that triangle ABC is congruent to angle DEF. All right. Now, if HL, which stands for hypotenuse leg, or RHS, which is right angle hypotenuse side, but they're both the same thing, right? So essentially what this states is that if the hypotenuse and a side of a right-angled triangle is equivalent to the hypotenuse and the side of the second right-angled triangle, then the two right triangles are said to be congruent by HL or RHS rule. So let's look. We know that XZ is equal to RT because they have the same length, maybe like 16 and 16, right? And we know that YZ is equal to ST, right? Because of this, we know that triangle XYZ is going to be congruent to RST, okay? And so those are the 5 ways that we can prove a triangle is congruent. If you have any questions about any of these, as usual, send me an email, message, or bring it to your deep dive lesson. All right, now into the really important part that does, where, you know, a lot of questions does come out, is the isosceles triangle theorem. And here is what it says in the theorem. So angles opposite congruent sides have equal measures, right? So let's look. We're given a triangle ABC, and this side length here is 1, and this side length here is 1, right? Because these two side lengths are equal, they're congruent. That means the angles opposite them. So as you can see, this angle here corresponds to angle C, and this side length corresponds to angle B. Because these two are equal lengths, they're congruent sides, we know that angle B is going to be congruent to angle C. All right. Now on the flip side also, so the inverse of it essentially, is that sides opposite congruent angles have equal lengths. So let's look. We're given triangle XYZ, and we're actually given angle 30. This angle is 30, and this angle is 30. Because these two angles are the same, we know that they're opposite sides, right? So this side here for angle Z and this side here for angle Y would be the same length. They'll be congruent lengths. They'll be congruent sides, which means we can tell that XY is congruent to XZ. All right? And so we'll actually be playing a lot with this. And this one does have a lot of questions come out in your ACT and SAT math questions. So we'll be paying a lot of attention on this during your deep dive lesson. Okay. Now some really good things to know in medians and perpendicular bisectors. All right? So a lot of things and theorems behind this. So one is if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So for example, let's look. So CP, right, is your perpendicular bisector of AB, which means that CA is equal to CB, is essentially what this means. All right. Now the other thing is if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So let's look. If angle BAD, so this angle, is equal to angle CAD, which is this angle, then that means DB would be equal to DC. All right. Now, the perpendicular bisector of a triangle intersects at a point that is equidistant from the vertices of the triangle. So let's look. We have, this would be the perpendicular bisector. So the lines in blue here are your perpendicular bisectors for each side of the triangle, right? So if we were to draw a perpendicular bisector, so draw, they will meet at point P. All right, as you can see. Based on this theorem, we know that PA equals to PB equals to PC. So these lines here would be the same length. All right. Now, next thing we need to also know is that the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So if we look, this is the angle bisector, this is the angle bisector, and this is the angle bisector. So essentially the blue lines are the angle bisectors, right? So they will meet at a point here, at point P. From this, we know that PD would equal to PE, and that would also equal to PF. All right. That's essentially what it means. And as you can see, this is a perpendicular line because of this right angle sign. All right. So essentially, this is what this theory means. All right. So now a little thing. So remember, a median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. All right. So the medians of a triangle intersect at a point that is 2/3 of distance from each vertex to the midpoint of the opposite side. So let's look. If P is the centroid, which is essentially the center of the triangle, so if P is the centroid of angle ABC, then that means AP is 2/3 of AD. So that means this is 2/3 and this is 1/3. PB is 2/3 of BF, so 2/3, 1/3. And CP is 2/3 of CE, so 2/3, 1/3. And this one is really, really handy to know. All right. Alrighty, and so we are at the end of our pre-lesson video on congruent triangles. If you have any questions about any of these concepts, as usual, send me a message, send me an email, or bring it to your deep dive lesson. Alright, good job listening to your pre-lesson video, and have a good rest of your day.